Next, we want to take what we already know, since we know all of the stuff from that first 2 pages already, perfectly know it. And we want to apply it to the unit circle so we can figure out what's going on at the quadrantal angles. And also, so we could start taking these sine and cosine functions and stretching them out on the number line. So we can't just have everything going in circles all the time. So we're going to look at this circle and we're going to say that this is a unit circle. The unit refers to the radius of the circle. So a unit circle is a circle with a radius of 1 centered at the origin. So the unit circle has a radius of 1 and the center at the origin. That means we're going to have coordinates going all the way around the circle. So at theta equals 0 degrees, when theta is equal to 0 degrees, the coordinates of this point will be at 1, 0. At 270 degrees, the coordinates of this point are going to be 0, -1. At 180, the coordinates there will be -1, 0. Then at 90 degrees, the coordinates up here will be at 0, 1. The coordinates going around the circle will tell us the sine and the cosine of the angle theta. So we find out where we are, the angle that we're at, going around the circle. Lay the terminal side, see where it intersects the unit circle, and the coordinates of that intersection. The x coordinate will be the cosine of theta, and the y coordinate will be the sine of theta. So the coordinates will be cosine theta, sine theta. The x coordinate is the cosine of theta, the y coordinate is the sine of theta. Let's take a look at what's going on in that first quadrant. Remember, in the table of values, sine started off at 0 and increased up to 1. Cosine started off at 1 and decreased down to 0. Those are descriptions of the y coordinate and the x coordinate respectively. Notice that our x coordinate starts off at 1. Here at 30 degrees, at 30 degrees, we'll have a cosine of 30 is √3/2. And sine of 30 is 1/2. At this 45-degree angle, we're going to have √2/2. I'm going to have to go sideways. I didn't make a big enough circle. And at the 60-degree angle, we're going to flip the ones at the 30-degree angle. The x coordinate is 1/2. And the y coordinate is √3/2. Then when we get to 90 degrees, cosine of 90 is 0, sine of 90 is 1. So going around the circle, the x coordinate tells us the cosine, the y coordinate tells us the sine. We can see those x coordinates start off at 1 and then drop down to 0. X is going from side to side, so x is 1. √3/2, which is about 0.8660. √2/2 is 0.7071. 1/2 is 0.5, and then down to 0. If we continue to go around the circle, we'll have the same values, 1/2 and √3/2, the same absolute values, but then the signs will change. Notice that in the second quadrant, the x coordinates are all negative, where the y coordinates are positive. So when we get to this 120 degrees, I'm going to take 1/2 and √3/2 and translate that over into the second quadrant. In the second quadrant, x is negative, so cosine is negative. So the coordinates here are going to be negative 1/2 and positive √3/2. In the second quadrant, x is negative and y is positive. In the second quadrant, cosine is negative and sine is positive. I use the same values, 1/2 and √3/2. I make the x's negative. At 135 degrees, which is 45 degrees in quadrant 2, the x's are negative, the y's are positive. So this point will be negative √2/2, positive √2/2. Then when we get to 150 degrees, our 30-degree reference angle, the x's are negative. So negative √3/2, positive 1/2. So those are the coordinates of those points going around. So we see in the second quadrant, the cosine is going to start off at 0 and drop down to -1. So we'll start off cosine of 0, cosine of 90 is 0, cosine of 120 is -1/2, cosine of 135 is negative √2/2, cosine of 150 is negative √3/2, down to cosine of 180, which is -1. So we can see cosine start off at 1 and drop down to -1 in that first half of the circle. And then we just have to go all the way around. In the third quadrant, both coordinates are negative. So the 210 will be negative √3/2, negative 1/2. The 225 at 225 will have negative √2/2, √2/2. And at 240, we'll have negative √2/2. Negative 1/2, negative √3/2. Both coordinates are negative because both sine and cosine, other way around, cosine and sine are negative. Then when we get down to theta equals 270, we'll be at the point 0, -1. So cosine has gone from 1 at 0 down to -1 at 180. And then not at 270, we're back up to 0. And then from 270 to 360, we'll go back up to 1. Here in the fourth quadrant, x's are positive and y is negative. So cosine is positive, sine is negative. So here at 300, we'll have a positive 1/2, negative √3/2. Here at 315, we'll have √2/2, negative √2/2. And then here at 330, we'll have positive √3/2, negative 1/2. And then when we get back up to 360, we'll have 1, 0. This seems like a lot to remember because it's a lot to remember, and you have to remember all of it all the time in perfect detail. The big advantage that you have is that this is the same information over and over again. It's just what we had in the first quadrant copied over into the second, third, and fourth quadrants, where the values ain't changing, the signs are changing. The absolute values aren't changing, the signs are changing. This is another way to remember what's positive where. Cosine is positive where x is positive. Sine is positive where y is positive. So it's not a bunch of separate things. It's one big interconnected thing. Any questions? Fortunately, out in the real world, all angles have a 30, 45, or 60 degree. Oh, wait, no, that's not true at all. Dang. So these are just some angles that make it helpful for us to learn trig. If we learn these values, it helps us get the flow of how cosine and sine work. Because what we need to do, eventually we need to introduce radians first. What we need to do is take these functions, cosine and sine, and instead of having them just go around a circle, we've got to imagine cosine starting off at the top, dropping to the middle, to the bottom, back to the middle, up to the top, and then just repeating itself as we go around the circle. Because graphs of sine and cosine, when we stretch them out on the real number line, will make waves up and down and up and down. And that's the model that we want to use for things that are periodic. They go up and down and just repeat. Any questions? How's everybody, okay? Everybody looks stunned. You all gonna be like this. But that's because this is an afternoon class. I don't know if any of you ate lunch, but either you ate lunch and you're too tired to pay attention, or you didn't eat lunch and you're too tired to pay attention. You're either too hungry to pay attention or too tired from eating to pay attention. So I don't know. I don't have all the answers. How's everybody, okay? As long as you remember that you did this to yourself, don't blame me. You signed up for this. I mean, is anybody surprised by the format of what we're doing here? Yeah, didn't think so. Wait, there's a math class and there's homework? And the teacher's just going to talk at us for the whole time? How's everybody, okay? All right, so like I said, you don't have to memorize this information. You just have to remember it, all of it, all the time, in perfect detail. Starting now, you have until Thursday to do that. Any questions? Comments? Snide remarks? It's way too early in the semester for snide remarks. All right, I don't think I have 250 in me today. I've only got 215 today. So that's going to do it for today. I think that's plenty, by the way. We'll all just pretend that we were here until 250. If anybody asks. That's going to do it for today. I'll see y'all on Thursday. Everybody have a good couple of days. Thanks for playing.